A lot of us have been there. You bring home a new pet goldfish, super excited. Maybe you want it at a fair or picked it out at the pet store. You get the bowl all set up, you add the water, and then you wake up the next morning and it's just gone. It is such a classic and honestly a heartbreaking first pet experience. So what is actually going on here? Let's figure it out. Right? It feels like this unsolvable mystery. I mean, you gave it a home, you gave it food, you did everything you were supposed to do. So why this sudden tragedy? Well, it turns out the answer is hiding in something we all use and trust every single day, without a second thought. And yeah, the culprit is the very water we pour into the tank. While our tap water is made perfectly safe for us to drink, the exact process that protects us creates a totally lethal environment for fish. This invisible threat? It's a chemical called chlorine. Okay, so what exactly is chlorine? Well, your local water facility adds it to the water supply for one very specific reason: to kill living things. We're talking about those nasty microscopic germs and pathogens that could make us really sick. And it is incredibly good at its job. The problem, of course, is that your new pet fish is also a living thing, one you're trying to keep alive. And this really lays it out perfectly. It's a total double-edged sword. For us humans, chlorine means we have safe, clean drinking water. But for a fish, that exact same chemical launches a two-pronged attack. It causes direct physical harm to the fish, and it wipes out the invisible ecosystem that keeps its little home livable. So let's start with the direct assault on the fish itself. Just imagine trying to grieve in a room that's slowly filling with a corrosive gas. That is basically what a fish experiences when it's dropped into untreated tap water. The chlorine immediately goes after its most vital organs, its gills. And the signs of this poisoning are pretty immediate and awful to see. The fish will often rush to the surface, just gasping for air, trying to get oxygen. You might see its gills and skin turning red and looking irritated, and its swimming will become jerky and erratic as the chemical does its damage. A user on Reddit put it about as bluntly and as perfectly as you can. Chlorine burns the fish's gills. This isn't just some minor irritation we're talking about. It's a literal chemical burn on the delicate tissue that a fish uses to breathe. It's catastrophic. And ultimately, that's what ends up killing the fish. With its gills so badly damaged, it just can't extract oxygen from the water anymore. So no matter how much it gasps at the surface, it is, for all intents and purposes, suffocating. But believe it or not, that is only half the story. Even if a fish somehow survives that initial chemical shock, the chlorine launches a second, much quieter attack on the tank's entire life support system. It's building up a whole new threat. You see, every single healthy aquarium runs on an invisible army of helpful microbes. This biological filter is absolutely essential. These bacteria are the sanitation crew. They break down the toxic waste that fish produce, and they're what turns a little glass box into a stable, healthy habitat. So here's how they do it. It's called the nitrogen cycle. First, fish produce waste, which in the water becomes highly toxic ammonia. Then, the first team of bacteria eats that ammonia and turns it into something called nitrite, which is also really toxic. Then, a second team of bacteria comes in, eats the nitrite, and converts it into the much, much safer nitrate. Without this two-step process, the tank just turns into a toxic sewer. And here's where it gets really fascinating. Not all these bacteria are created equal. The Nitrosomonas, the guys that handle that first step, they're actually pretty tough. They're less sensitive to chlorine. But the Nitrobacter, the crucial bacteria for that second step, they are extremely sensitive. So when you add chlorinated water, you might not kill the first colony, but you can absolutely devastate the second one. The whole cycle breaks, and you get this massive spike of toxic nitrite poisoning any fish that managed to survive the initial chlorine burns. So at this point, you might be thinking, okay, easy. I'll just let the water sit out for a day, the chlorine will evaporate, problem solved. And you know what? That used to be a pretty reliable trick. But these days, a lot of water companies have added a little plot twist that makes things way more complicated. Meet chloramine. It's a compound that's made of both chlorine and ammonia. And it's way more stable than just plain chlorine. That means it sticks around in the water longer, which is great for disinfecting. But for fish keepers, that stability is a huge problem because it won't just gas off and evaporate if you let the water sit out. And this is the chemical trap it creates. When you add a basic, old-school dechlorinator, it breaks that chloramine molecule apart. It does its job on the chlorine part. But what's left behind? Ammonia. You've just fixed one problem by immediately creating another highly toxic one right in your tank. Okay, so tap water is basically a minefield of chemical threats and ecosystem killers. But here's the good news. Making it safe is actually really straightforward, as long as you know the right steps. It's all about neutralizing all these threats before that water ever gets near your fish. All right, so here's the playbook. First, letting the water sit for a day is still a good idea for any basic chlorine that might be in there. But the absolutely critical step is number 2, using a modern water conditioner that specifically says on the bottle it neutralizes both chlorine and chloramine. Many will even handle the leftover ammonia too. After that, it's just about stability. Checking the pH and hardness to make sure they're in a safe range, and always matching the new water's temperature to the tanks to avoid shock. This quote from the YouTube channel Girl Talks Fish just hits the nail on the head. After making this exact mistake herself, she started using a checklist. It doesn't matter how experienced you are, simple routines are what prevent big mistakes. It's such a small bit of effort to protect the little lives you're looking after. And all of this leaves us with one final, pretty big thought. We just went through all the ways that chemicals designed to protect us are deadly to a tiny fish. It really makes you wonder, doesn't it? If our water requires this much treatment just to be safe for a goldfish, what other invisible things might be in the water that we drink every day, and what are their long-term effects on us?